Basic proportionality theorem, also known as Thales theorem. Or BPT. Now this theorem says that if a line is drawn parallel to one of the sides of a triangle, then it divides the other two sides in the same ratio. So if we are drawing a line parallel to one of the sides of a triangle, let's say from this figure we can see EF is being drawn parallel to BC. EF is parallel to BC. So this line EF will divide AB and AC in same ratio. And what will that same ratio be? See, AB is being divided into two parts, that is AE and BE. Same way AC is being divided into two parts, that are AF and FC. So if EF is parallel to BC, then we will have that AE upon BE equals AF upon FC. This is the result for BPT. So this is basic proportionality theorem and this is the result for BPT. This is the given part in BPT and this is what we need to prove. Okay, so let's get started with the proof of BPT. Given. First let me draw a triangle again. So given a triangle ABC in which I have a parallel side EF. So the triangle is triangle ABC and it has this side EF and EF is parallel to BC. So in which EF is parallel to base BC. What do I need to prove? I need to prove that AE upon BE, the ratio of AB. Okay, AB is being divided into two parts. The two parts are AE and BE. This ratio is equal to the ratio of the other side, which is AF and FC. I'll have to do a small construction over here. The construction will be So this is the construction that I've done. This is perpendicular, this is also perpendicular. Let's mark these points as M and N. Okay, now construction that I've done. First, let's say join BF. I've joined B and F. Then join EC. I've joined them also, and draw MF perpendicular AE, or you can say AB, and NE perpendicular to AF or AC. Now coming to the proof. So in triangle ABC, sorry, not ABC, in triangle AEF. In triangle AEF, if AE is the base, then we can see MF is perpendicular to AE, so MF will serve as height. Okay, base is AE, MF is height. So area of triangle AEF is equal to half into AE into MF. First equation. Similarly, now in triangle EFB, this triangle, in this triangle EFB, this time BE will be the base, but height will remain MF. Okay, MF will remain the height of this triangle, because only a perpendicular side can be the height. Okay, it's always a perpendicular to the base that makes the height. If I slightly extend BE, if BE is slightly extended to M, so you can see it becomes BM, and MF is perpendicular to BM, so MF will be the height. Okay, so if BE is base, MF is height again. BE is base, MF is height. So area of triangle EFB, half into base BE into height MF. This is the second equation. Now moving on to the other side. Okay, the other side will also be dealt the same way. We have to make equation for the other side, AF and FC. Okay, so this is how I'll be making the ratio the same way as I have done. Okay, but I haven't made the ratio, so let me make the ratio also. So I'll divide first equation by second equation, and it becomes area of triangle AEF upon area of triangle BEF equals half into AE into MF is the height upon half into BE into MF is the height. Cancel out the common things, half half, MF is gone. So what do I get? I get area of triangle AEB upon area of triangle BEF equals AE upon BE. So I'll mark it as equation A. Now same thing, the way I made this equation and the ratio, same thing I'm gonna do with the other side of the triangle. Right now I did it with side AB, now I'll do it with side AC. So again in triangle AEF, this time AF is the base, this is the base AF. So what will be the height? this perpendicular to AF will be the height. EN is the height. So area of triangle AEF equals half into base AF into height EN. First equation, third equation. Now in triangle, the lower one, this one, in triangle CEF, this time CF is the base and again EN will be the height. So CF CEF CF is base and NE is height or EN is height. So area of triangle CEF equals half into CF into NE. This will be the fourth equation. Now let's make the ratio third divided by fourth. It becomes area of triangle AEF upon area of triangle CEF equals, again the same things will get cancelled, so half and half will get cancelled and NE and EN will get cancelled. They're the same thing, so it's AF upon CF that we are left with, because we have done this thing already in the first part. So I'm not doing the entire working here, because we can clearly see something will get reduced. Now I have equation A, I have equation B. In both the cases I have triangle AEF. Triangle AEF is the same triangle. It is the triangle which is drawn up. Sorry, there's a slight mistake. Now coming to AEF will surely be equal to AEF. Every triangle is equal to itself only. But now what about the triangles in the denominator, BEF and CEF? So now we have a property that triangles on same base and between the same parallels are equal in area. Triangles on same base and between the same parallels are equal in area. So when we look at triangle CEF and triangle BEF, just have a look here. This is triangle BEF and this one is triangle CEF. They both are between the parallel lines EF and BC. EF and BC are the parallel lines where triangle BEF and CEF are there. Okay, so these are the same two parallel lines where these two triangles lie, and EF is the same base for both the triangles. It's BEF, EF is the base, CEF, CEF is the base again. Okay, so we use this property over here. Triangles on the same base and between the same parallels are equal in area. So because of this we have area of triangle BEF equal to area of triangle CEF. If you still have any confusion regarding this, I'll name the parallels and the base. Same base EF and same parallels and same parallel lines that are EF and BC. So these EF is the same base and EF and BC are the parallel lines. So these two triangles are same, equal in area. It implies equation A is equal to equation B. Why? Because area of triangle AEF will definitely be equal to area of triangle AEF. There's no doubt regarding this. But then I'm dividing both of them by area of triangle BEF, and this area of triangle BEF is equal to the area of triangle CEF. And yes, they are equal because they are on same base and between the same parallels. So from A and B, what values do I get? From A and B I have AE upon BE, you can refer back to the previous part, equals AF upon FC. So here I have BPT proved. Now, but I'll slightly extend it. If you have been asked to state and prove BPT, this much is the solution that you need to do. But now I'll slightly extend it, because you have seen that we had a big triangle and that it was ABC and EF. I can also get the ratio that AE upon AB equals AF upon AC. Let me show you how. Okay, now it's done, but now taking reciprocal. When I take the reciprocal, what will I get? I'll get BE upon AE equals FC upon AF. Now adding 1 to both sides. I'll add 1 on both sides. So I get BE upon AE plus 1 equals CF upon AF and plus 1. The denominators are 1 only. Now taking the LCM is AE on the left side and AF on the right side. So the numerator becomes BE plus AE, and here the numerator will become CF plus AF. What is BE plus AE? BE and AE. So AE and this BE, when they both are added, it becomes AB. Same way AF and FC, they join to form AC. So it is AB upon AE equals AF upon FC. Again I'll take the reciprocal. And I get AE upon AB equals FC upon AF. It's AF. And this will be AC. Okay. It's a slight error. Everything was going right, but just a copying mistake. So it is AF AC upon AF, and it will be AF upon AC. Okay, so this is an extended result of BPT that you will see, and as we move on with similarity you will be able to use it. AEF BC. So see, AE, which is a side of smaller triangle, upon AB, which is the entire triangle side. AB is the side of entire big triangle, equals AF upon AC. AF is again the side of smaller triangle and AC is the side of bigger triangle. So I have I can take it as two different triangles, AEF and ABC. So I'm getting AE upon AB equals AF upon AC. This is what I'm getting. Now we'll be solving some questions also on BPT. So you can just have a glance at this and I'll get a question. So here I have a triangle ABC and this is point D and this is point E and they both are parallel to each other. They have given us that AD is 1.5 centimeters, AE is 1 centimeter, this is 3 centimeter and so on. And now I need to find the missing side. They've also given that yes, DE of course parallel to BC, and it says that find AD, find EC, EC. Okay, in this part I need to find EC. So here I'll simply use BPT. I'll not use the entire theorem. I'll not be stating and proving the entire theorem. I have the result for BPT. Okay, so since my solution will be so DE is parallel to BC. So by BPT I have the result that the ratio of the sides will be same. AB is being divided into two sides, which is AD and BD. So AD upon BD equals AE upon EC. Okay, so this is the ratio that I get. Now I'll just substitute the values. AD is what? 1.5 upon what is BD? It's 3 equals AE, which is 1, and EC is what we need to find. So let's reduce it. Point is gone. We remove the point. We put a 0 in the denominator. 15 ones are 15. 15 twos are 30. So I get 1 upon 2 equals 1 upon EC. So I'll just reciprocal it and get EC equals 2 centimeter, because 1 is equal to 1, so 2 is equal to EC. So EC equals 2 centimeter. Let's try one more question. By the time you may see this. Again, naming the triangle ADE, B and C. So from here I have AE is 1.8 centimeter, this is 5.4 centimeter and 7.2 centimeter, and I need to find AD. Again the question says, these are NCERT questions, the first and second question of your second exercise of chapter triangles. Again it has been given to us that DE is parallel to BC. So if DE is parallel to BC, what will I do? Again I'll use BPT. So DE is parallel to BC, so by BPT I can say that the ratio will be same. So AD upon BD equals AE upon EC. So I can easily find the missing side from here by substituting the values in this ratio. AD upon BD is 7.2 equals AE is 1.8 and EC is 5.4. Now I'll make the ratios. So first I'll just cross multiply it over there, so it becomes AD equals 7.2 into 1.8 divided by 5.4. I'll cancel out the decimal points, so it becomes 18 upon 72. So 18 ones are 18 and 18 threes are 54. Then 3 ones are 3 and 3 twos are 6. Point, because there's a point here, so I put a point in my value also. What I'm getting after reducing, 3 twos are 6, 7 minus 6 is 1, 1 2 and 1 and 2 becomes 12. So 3 4s are 12. So the value of AD is 2.4 centimeters. That's it. We'll do more questions ahead, the proving questions.